Chapter 13, which is post-exploitation. And so we're going to talk about interpreter and scripts, post-exploitation modules, railgun, and local privilege escalation. And there's more in this chapter that we'll do later, which will be in 3 weeks. So at the interpreter prompt, you can do help, and you'll see all the commands that are available. You can use -H to get help about a specific command, or help command to get help about it. And so when you have Metasploit sessions open, you might very well have several Metasploit sessions open, either because you have several targets or because you are struggling to get control of a device and you are trying to escalate your privileges to root or above it to system on Windows. And so I often have one session without privileges, another session with privileges, and so on. So you have to manipulate them. Sessions will show you all the sessions. You can interact with -I and a session number to interact with one session. When you're done interacting with a session, if you exit, that will close the session. And if you want to do something else, but you might want to come back, you use background to get out of the session without closing it and get you back to the MSF prompt. So that's quite useful. You can also use shell to go from a interpreter session down to a command shell session. So you can execute direct Windows commands or bash commands, depending on what you're taking over. And then when you exit from a shell, you will be back in interpreter session. You can upload things with the upload here. If you do upload files, if you're uploading to a Unix server, you can just type in the path of what you want to upload. But if you're uploading on the path on a Unix system, uses / and it's fine. The path on a Windows system uses backslashes, and backslashes are not fine because backslash is a meta character on Unix, so you have to use 2 backslashes. Every place you would use one. The first backslash tells it not to interpret the second one as a meta character, but as a literal character. All right, so Windows, there are several handy Windows binary included in Kali. You've got backdoors and keyloggers and netcat and VNC viewer and wget. Lots of commands you might want are right there to upload to Windows systems so you can execute them. All right, so I'll mention a few projects here. This one here is good, clean, fun, RAM scraping. This is the technique used to steal the credit card numbers from Target a couple of years ago. It's very powerful. Passwords are almost always in plain text in RAM. Pretty much everything is always in plain text in RAM. Anything that's processed is just left hanging in RAM until that RAM is reused. So stealing it right out of RAM is very powerful. This is entirely unnecessary, by the way. Microsoft has a special variable type. I've forgotten the name. They have a transient variable type since 2004 in Visual Studio that you could use for secure data. Where you put something in RAM, it is used, and when you let go of it, it's erased. Microsoft thought of this and put in a countermeasure, but as far as I can tell, nobody uses it. So if you look in RAM, you'll find the passwords you typed in a browser in there and everything else because the developers just didn't use the variable type that would evaporate after use. Probably time to mention another project I just added, which is really important. The students just got back from the pen testing contest, and although they didn't win, we all learned a lot, and I certainly learned how to teach this stuff better. So I wrote a project here where you do a proper pen test. So here's the stuff. This is the documents the students made. So here is the point of a real pen test, which I sure understand a lot better after this contest and the explanations that went around it. So first you prepare by making a contract, finding out what the customer wants and all that. Then you have recon and scanning. You gather information about the company from the outside, and then you do things like port scanning, vuln scanning, and so on, and scan it with various tools like Nikto and Derby. Derby will find all the, it's Derbuster, Derby, it will find all the files on the server if they have common names or in common places. For like a web server, and Nikto will find web server vulnerabilities and so on. So you find vulnerabilities, then you exploit, and this is as far as I've been thinking. But what they made a big deal out of at this contest is that exploiting the server is not even half of the job. Just getting root is actually not really very important at all. What they really want is a thorough list of all their vulnerabilities and what countermeasures are needed, and they want it to be sorted in order of what will harm the business the most. Often, a root exploit is not really what they're worried about. They're worried about, say, getting in the database, which might be encrypted or something. So a root exploit is often a path towards getting what's in the database, but what they really want to know is what's really going to hurt their business the most and how to patch that. So once you get shell or root shell, then you can do things like here, and you're not done. And this is something that I certainly hadn't thought of. I find one way in and I think I'm done, but that's not what they want at all. They want you to, gaining control of the server is a useful tool, but the real goal is to figure out all the ways in and decide which ones matter most to the real business of the company. So anyway, once you're in, you do post-exploitation, now you have to take a look and see what else is wrong with that box. Like how many ways are there to escalate privileges, and how many ways are there to get into whatever's important, which is probably something like a database or a web page or something, whatever the business of that thing is. And then you have to prepare a report that explains this stuff. Your report has to have a 1 or 2 page executive summary that explains your major findings and what the mitigations are, followed by an appendix, which is technical details in sufficient detail so that their technical team can understand what you've done. So I gave you one here to do here. I've set up a target VM that is vulnerable. Download this thing and run it. It'll be listening on this address and do all that, which is what we should all be practicing to get ready for these contests and also for real employment in pen testing. So scan it, research the vulnerabilities, exploit it. After you've got control of it, take another look at it and see how many problems you can find, and then write a report. And I'd like you to present the report. Do as much of this as you do. It's all worth more points. And I think in 140, starting next semester, the students that really want to be in competitive teams will be practicing doing this with limited time. This one here, I make a homework assignment so everybody has plenty of time to do it, but then you could show up and you could have like 3 hours to do this, which is, here you had like 8 hours. And that's a little more advanced, but that's what we should be practicing, is all these steps. So one thing you have to do is have some kind of orderly system, like a spreadsheet or something, where you keep track of the IP, the name of the system, the open port, service version, and other notes. So you, as you scan a network and find a dozen machines, you have a basic idea of what's going on each machine, and then different people can analyze which one, or you can use different tools, and you make sure you're not duplicating efforts. And that's the game. So give this thing a shot if you're serious about this. This is the real process of a real pen test. And in this class, I put it in as an extra credit project. In 140, it'll probably be required next semester. Maybe not this semester, maybe this semester. I'm not quite sure about that yet. But check it out. Anyway, so there's 15 is RAM scraping. All right, so once, here's hash dump. Hash dump is great fun. Once you are, you can dump hashes here. Now, you often don't get them all unless you're system. That's some of the administrator. If you want to get system is a fantastic tool that will elevate you to system on most Windows machines, and it tries a bunch of tricks. And it's worth knowing how. It'll try impersonating named pipes, which is trying to connect to services that are already running a system. Then it'll try to duplicate a token if it can find one to be a system. And there are other ones that will be used by bypass UAC, works by process injection. And these things are very smart. And the reason they keep working for year after year is because they exploit weaknesses in Windows that Microsoft does not want to change. Because Vista was not vulnerable. Vista was really strong with user account control, and it drove everybody nuts. Every single time anything had to escalate to administrator, it would pop up a box and ask you. Now that's secure, but nobody can stand it. So they deliberately removed some of those, and those are open doors through which you can escalate. But they can't put them back without driving all their customers nuts again. So they haven't found a good solution to that. So in the meantime, they're just leaving some open doors. There are certain ways to escalate that will not cause the prompt to show up. So it used to be, up until about 3 years ago, that Java was just a wide open door to every machine. You could just run a Java exploit. It wasn't even an exploit. You could use a Java feature as written, which gave you remote control of the machine. It's built into it. It was built into Adobe PDF Reader for a long time too. It was just a known feature. It was not a bug as far as they were concerned. They finally got tired of everybody owning you through Java and put in like some warnings and stuff that slowed it down. And in the same spirit, Microsoft will probably have to have some kind of countermeasure for this, but in the time being, they haven't. So there's a lot of interpreter scripts. You'll find them here in User Share Metasploit Framework scripts. Interpreter, they're all Ruby scripts, and there's a long list of them here, and they have pretty fun names like enumerate Chrome and Firefox. I'm pretty sure those will steal the passwords out of Chrome and Firefox. Now you can put a master password in Chrome or Firefox, but if you don't, it's all just right there in plain text. This is what I keep giving Android app developers trouble about is storing extra copies of your password somewhere stupid on the system, and very few Windows apps do it, but some of them do, like browsers. And Firefox will totally store a plaintext copy of all your passwords and show them to anybody that borrows your machine for a second if you don't put a master password on it, which it does not by default. This is a fairly common trick. You can just go view the passwords in anybody's Firefox. Anyway, there's a whole bunch of these that are fun. I picked out the few that seemed like the most fun to talk about. Technically, they're all deprecated. You're not supposed to be using scripts. You're supposed to be using post-exploitation modules instead. And in fact, a bunch of these scripts still work. As we all, I've probably mentioned this before, ifconfig was deprecated like 8 years ago. We're not supposed to be using it. We're supposed to be using something else called IP. I tried this. It's not even on the Mac. It's not even in BSD. Whoever tells us it's deprecated, I don't know what they're smoking. We're still using this stuff. I mean, the fact that it's deprecated doesn't mean it doesn't work. It means supposedly every developer that wrote all these things is supposed to write it again in some other way. And I'm like, yeah, sure. I bet half of those guys quit or died or got a job or something and are otherwise not available, and on it goes. But one dirty little trick is any long list of attacks like this, just like my projects, after about 2 years, about half of this stuff won't work anymore because things change and get updated, and the person who developed the tool doesn't keep updating it to keep up with the changes. So be aware of that. Anyway, auto run script is good, clean fun. You remember, if you take over something through like a browser exploit, then as soon as the user closes the browser, you lose control. So you want to migrate to another process, and you can do it manually, but you can also set an auto run script which will automatically migrate to Explorer.exe as soon as it gets a shell, and that's what you should do. That's what the real malware does. Then you will not get, it'll process, as soon as you connect and get a shell, it processes auto run script and moves to Explorer, so instantly you move to another process, and now you're good until the user logs out. All right, so you can run scripts. You can use -H to get information about it. Here's details about the migrate script. You could kill the original process if you want to. That might be something you want to do, like you kill their browser. They say, oh, my browser crashed. They're not going to assume they've been hacked. They'll just assume this is browsers acting the way they normally act. And on you go. You can specify the process to migrate to. By the way, if you don't specify the process, there's one of these that will it'll automatically launch Notepad and migrate to it. That's why there was a saying from CCDC a couple of years ago. They say, check Task Manager, and if you see Notepad, you're owned. It was fairly common for people to launch Notepad and migrate into Notepad. Anyway, the Prefetch folder you can get with a Meterpreter script. This will dump the contents of the Prefetch folder. This is a very handy folder. The purpose of this is to use all the extra RAM. When Windows XP came out, a lot of people put in like 2 or 4 gigs of RAM, and Windows XP only used about 1/4 of a gig of RAM. So all that RAM was just sitting there doing nothing. So in order to get some good out of it, Microsoft chose to preemptively load things into RAM that you might launch pretty soon, so that when you did launch them, they would open faster because they didn't have to fetch them from disk, and that's called Prefetch. And in order to populate that list, Windows 2000 started this, and Windows XP and later versions enhanced it more. Windows attempts to watch your behavior and customize itself to make it easier for you. So they are tracking everything you do to change the order of items in lists and such. And one of the things they do is keep track of the last 128 programs you have launched and put it in this folder called Prefetch, which they use to preemptively load them into RAM, which is extremely useful for forensic investigators and a lot of other people. You can just see the last 128 things that were launched, when they were launched, and who launched them by just looking in the Prefetch folder. And you can do it through Metasploit on any target. You can dump contents of memory. Process memdump will let you choose a PID or the name of a process and then dump the memory just for that process. Now you could dump all the RAM from the computer, but that would be really big, like 4 gigabytes, and you have to hunt through that for your stuff. But probably what you want is just the memory from something like Internet Explorer that has login passwords that were typed into a web page and things like that. So that's good, clean fun. And then there's persistence. Remember, if you take over a browser, you only own the machine until they close the browser. If you migrate to Explorer, you only own the machine until that user logs off. But if you want to own that machine forever, you want a persistent mechanism, and that means essentially you need a rootkit. Now, you could download a real rootkit and install it, but this makes a poor man's rootkit out of a Metasploit attack. All this does is automatically make a Metasploit payload and put it on the machine by default in temp, and then make a registry key to automatically run it. Now the problem with this is antivirus will almost always catch it. But if they don't have antivirus, or if you have taken sufficient measures to conceal your payload from antivirus, then this is pretty good. This will automatically keep relaunching a service every time they restart the machine, so you maintain control of the box until they actually figure out what you've done and block it. Here's a cute one to bypass McAfee virus scan. What this does is upload an executable and then add it to the exclusion list. Remember, your antivirus does have a list of folders not to scan, and you can change that and then not scan the folder. So that's good, clean fun. Here's other ones. ARP scanner for fast host discovery. We're using that in a pen test a few days ago. And kill AV sounds pretty good, but there's no information in help. I kind of wonder how good it is, but if you could really kill the antivirus process, that would sure be handy. All right, so I got a few cahoots about this stuff. Okay. All right, what command starts interaction with a session? All right, that's it. Sessions minus I1. We'll start with interaction with session number 1. All right, what technique improves persistence? All right, that's my grade, of course. I wonder if I can make this bigger. Looks like I can make it a bit bigger anyway. All right. All right, what script gets plain text passwords? All right, memdump, you get them out of RAM, good. And what script shows the last 128 hey? Okay, good. Question, 128 programs run, okay. That's prefetch, good. All right, so let's proceed. All right, so here's the post-exploitation modules. There's a directory structure of these things. If you go to User Share Metasploit Framework, you'll see here modules. And if you go in there, you will see auxiliary encoders, exploits, SNOPs, payloads, and post. If you go into post, they're separated by operating system. AIX, Android, Cisco, Firefox, Linux, multi. Multi means it runs on multiple operating systems. And usually, most of the time you're in Windows. If you go into Windows, it's again separated into things that capture, escalate, gather information, manage sessions, recon, and wireless attacks. So, you know, there's just an awful lot of attacks in Metasploit, and a lot of the work comes post-exploitation. Once you've taken over the box, now you have to loot it. And there's a lot of tricks here to help you do that. So here's gathering out of the box. I thought a few of these were good, clean fun, like Bitcoin Jacker to steal your Bitcoin credentials. That's good, clean fun. Oh, that was the news article I somehow skipped. There's Ethereum had yet another disaster. After the DAO caused $30 million to be stolen by bad guys, followed by $60 million stolen by the so-called white hat hackers to force them into having a fork, they now had another system that was written so badly that an amateur playing with the commands was able to destroy $300 million worth of Ethereum. So it's gone forever. And Ethereum, just like they did last time, they're trying to say, this is not our problem. We run the blockchain, and if you idiots write apps on the blockchain that crash, that's your problem. But, as before, the people who invested in that are trying to say this is so much money you have to make an exception and fork Ethereum again. There are now, I think, at least 4 versions of Ethereum out there for previous forks because of similar disasters. 2 versions of Bitcoin, I think a 3rd one now, supposedly another fork next month. It is madness, and somehow all these forks do not seem to lessen the frenzy of buying, causing all the Bitcoin prices to be up in the sky I don't have any magic powers, but I certainly wouldn't buy any cryptocurrency right now. I don't believe that its current price is in any way justified. I think what we got is all the Me Tooers jumping on board, pumping it to far above any actual value. I would wait for it to crash, which will probably happen in about a week or two, and buy it then if you want to. But anyway. So here's a lot of gathering modules. Here's a few. There's the Bitcoin Jacker. This will download any Bitcoin wallet files. Now, if you have a proper Bitcoin wallet, like we're using in the 141 class, you ought to be encrypting it, so that even if somebody steals it, they can't get in, but some people don't. And then they put it on a machine connected to the internet, and then they get hacked, and well, you know. That's the first consequence of computerized money, is it's even easier to steal than the other kind of money, which everybody can see right away. Just like when they first brought out wireless networks, nobody would buy them because even an average person with no particular technical knowledge says, that can't be safe. My data is just spraying around everywhere, and indeed it was. Anyway, so here's Ntl and Downgrade. The Microsoft, after Loft Heavy Industries, made a mockery of Microsoft security by stealing passwords right off the network wire. Microsoft was motivated to improve their network transmissions and use stronger hash functions in several generations, and now they use SMB version 2, which has several layers of encryption on what goes over the network, but you can run this, and it will change a registry value to downgrade you to the old hashes that are easy to crack, the same one that Loft wrote, the LM hashes. Back in, say, the days of like Windows 95 and such, and DOS, they used these LM hashes, which are trivial to crack. And you can always use a downgrade attack to go back for them because Microsoft Windows is backward compatible with those really old systems. That's one thing about Windows. One of the reasons they make so much money is because if you have a company and you've been using Windows for 20 years and you have stuff you wrote 20 years ago, you can keep on using it forever because Microsoft always maintains backward compatibility. Apple ruthlessly does not. Anything 2 versions back, they totally ignore it, and they have no mercy. And therefore, if you're a company and you invest in $1 million of Apple devices, in a few years you're sorry you did that because the old stuff won't play with the new stuff, and Microsoft is aware of that. So they have downgrade options in all their products to cooperate with really old junk, which of course is bad for security, but it does help businesses continue to get value out of their old hardware. You can enumerate the logged in users. This shows you who is currently logged in and who has recently been logged in. So it gives you some user accounts to attack. So here it is, finding the currently logged in user is the administrator, and here's recently logged in users, student, strong, and administrator. So I don't know how far back it goes, but you can go pretty far. You get some information. Then you can gather credentials. There's a whole folder full of things that steal it from various things like Smarter Mail and VNC and FileZilla, and of course domain controllers. You can steal lots of credentials. If you have an auto login, which is kind of screwy, you can, in Windows, if you do control user passwords 2 at a command prompt, you get a control panel that lets you turn on auto login and type in a password, and it will always automatically log in with that password. And if you do, that password is saved someplace unsafely, and this module will steal it. It's not on by default, though. And typically, if you try it on, let's say, the Windows 2008 that I gave you in this class, it's going to tell you can't do it because this is not configured to have auto logon password. It's only going to happen if you've actually configured that feature, and you'd have to be kind of strange to configure that feature, I think. If you want it to automatically log in, the simplest thing is just have one administrator account with no password, and it will automatically log into that. But anyway, in fact, I tried using the auto login password because one of our labs here, the image installed by someone else before I learned how to defeat deep freeze. The administrator, the network, whoever it is around here that installs machines wrong, they installed the machines with a password and then put an auto login on the password, and the students didn't know the password, so you'd turn it on, it would log in, then it would go to sleep after 5 minutes, and you couldn't unlock it because you didn't know the password. So it was like really pretty stupid. Just having no password would have been a much better way to accomplish what they wanted, which is students can use it without having to log in. Anyway, and then there's Mimikatz, of course. Mimikatz is great fun. And this is part of Mimikatz giving you a single sign-on collector. The whole point of Mimikatz is to exploit single sign-on. Microsoft has a variety of systems to such as Kerberos tickets and some other things stored in RAM, which are all used to sign into multiple devices in a network. So in order to have single sign-on, they have to have some kind of credential stored which is reused, and if you can steal that, you can now log in as that person, and that's what Mimikatz does in many ways. All right, and that is on by default, single sign-on. That's, if you're in a domain, that's on by default. And as you know, Mimikatz can find your plaintext password. It's just sitting in RAM in case you might touch another company server and you want to get there. It's stored with reversible encryption in RAM, but Microsoft's encryption routine was cracked years ago, and there are several products that reverse it, including Mimikatz and Windows Credential Editor. Then there's gathering modules. These will loot information from the host. A variety of ways. You can steal some kind of BitLocker information, although I kind of doubt it's really going to be the BitLocker encryption key. That would be awesome, but supposedly you can't get that. It's supposed to be stored in a trusted platform module and not in the address space of the processor. But knowing Microsoft, I wouldn't be too surprised if there's a copy in RAM somewhere to steal. I don't know. Anyway, here's the gathering modules I thought were fun. There's a lot of them. Here's one that checks to see if you're in a virtual machine. That is often important to know. And we talked about this in the malware analysis class, and there's now malware that checks to see if you're in a virtual machine and changes its behavior. There's also malware that checks your public IP address to decide if you're an antivirus company and decide not to do anything bad if you're an antivirus company analyzing it, and only run if you're on what appears to be a victim, and so on. But most malware is not that smart. Here's the check VM working, telling me this is a VMware virtual machine. I've often wondered about making covert virtual machines. Virtual machines are extremely blatant. If you look at the first 3 bytes of the MAC address, that'll tell you VMware. If you look at the name of the network adapter, it'll tell you VMware. If you look at registry keys, it'll tell you that. But it seems like it would be pretty easy if you wanted to change all those to more realistic fake values and make it hard to tell that you're in a virtual machine. I'm just not aware if anyone's gone to the bother of doing that. Anyway, here's BitLocker recovery passwords. In the default AD directory, does not require domain administrator. I haven't played with BitLocker much. It's hard to believe that the BitLocker recovery password is actually just sitting there to steal, but maybe it is. It'd be pretty awesome if it is. And then there's Lsa Secrets. These things are amazing. This is another single sign-on system where Microsoft stores secrets, and in case you're going to connect to an FTP server and then connect to it again later, they don't want to bother you asking for the password again, so they store it where they can get it. And this used to have the plain text password of the primary administrative user in Windows XP that was never removed at all, so you could just get it even if another person logged in. And it has less in the modern version of Windows than it had in the old ones, but it still works. Lsa Secrets still has stuff that shouldn't be dumped out. Here it is working on Server 2008, and it gets the password here, p@ssw0rd followed by some junk. It's a little garbled, but it's there. You can get the currently logged in user's password here, as well as you might get it with Mimikatz. It's technically stored in yet another place. So Windows all by itself keeps a lot of extra copies of credentials lying around, and you can steal them with these various tools. Here's memory grep, which sounds great. So not only, instead of dumping all the memory from a process, downloading it, and then grepping locally, you could grep on the target system, which sounds good for like the word password. The only problem is it doesn't work, not on Server 2008. I didn't get any good out of it. As I mentioned before, these modules were invented by somebody at some time, and they worked at that time, but they probably, many of them have not really been updated for the latest versions of Windows. And I suppose this probably worked on Windows 2000 or Windows XP or something. So here's a cute alternative to using Mimikatz. Here's the Ntl and Downgrade Attack. You set up a Metasploit SMB listener, and then you trick people into connecting to it, and you downgrade it so they will send you the old time of hash. There's some information about attacks that did that earlier. The most powerful one, I think, here is a tool we're going to see next time. Remember what it is?
Responder.
Responder, that's it. Responder is the coolest way to do this. It's now included in Kali by default. You run Responder on a Windows network and just leave it going, and it will trick machines into authenticating to it and just gradually accumulate more and more credentials. It's bloody awesome. And all these Metasploit attacks do limited, more directed versions of the same thing. Then here's a phishing module that will phish Windows credentials. So it will pop up a login prompt. The idea is to have them believe that they've timed out and they have to log in again. I know this works a lot better on the iPhone. There was a big guy getting mad about this a while ago. The iPhones, of course, pop up a stupid box all the time telling you have to log into iCloud, so you can totally pop up a box that looks like that, and people won't think it's suspicious. And you can do it to some extent on Windows too if you make them think it's timed out from inactivity. Anyway, this one didn't work at all. On Windows 7, this box pops up, but the password never makes it to Metasploit. So I think it's again one of those modules that has not been updated to work on the latest versions of Windows. All right, here's one that enumerates Internet Explorer, getting user data, history, cookies and credentials, and HTTP auth passwords. Sounds pretty awesome, but it didn't work for me on Windows 2008. So again, I think these really powerful ones, I think Microsoft is aware of them and patched them, and the exploit has not found a new way to do it. And there's management modules, do things like migrate and kill AV. Here's inject certificate authority. That's good, clean fun. If you want to man-in-the-middle HTTPS connections, the nation-state way to do it is to pressure or bribe a real certificate authority into giving you a real root certificate. But the alternative is to just push a fake certificate into the trusted browser store, and then the browser will let you man in the middle and will not complain. So that's pretty good. Then there's a Microsoft SQL authorization bypass. This will try to get local system privileges, then migrate to the SQL Server process, and it can now make you the administrator over the database without having their credentials by taking over the process directly. And here is one that you can pay $100,000 to get with the Encase Enterprise Edition, where you can do a remote whole drive image. This will mount the hard drive over the network as a remote disk, and then you can just copy the entire contents of the hard drive over the network. And this is very commonly done at companies. This is a enterprise forensic issue. If you have someone in your company and you're afraid they're doing something bad, one thing you often do is you want to collect the evidence in a subtle way, because you might have many suspects and you might not want to insult the innocent people by interrogating them and kicking them out of the room and seizing their machine and accusing them of doing the bad thing. So you instead image their drive over the network through the workday, examine it, and you have your proof without them ever knowing anything happened. And you can do it with Metasploit also. And of course, there are great advantages to this. If you image the entire drive over the network, then BitLocker doesn't do anything, because the operating system is running and decrypting the contents of the hard drive. So that isn't protecting them. And another fun thing is you're getting all the unused sectors of the disk, so you will be able to get deleted files. This is a very common mistake criminals make, is they find out that the cops are coming, so they delete their files. And all that does is put a nice red arrow pointing to them for forensic examiners. Since deleting them doesn't get rid of them, they just look at recently deleted files. Thanks, I would have had to hunt through all this junk to find your awful stuff. Now you told me right where it is. Anyway, so that's good, clean fun. And of course, since you're doing it over the network, you can presumably be doing this before they know you're onto them. So they aren't even taking any countermeasures yet. They think they're still getting away with it, and you're getting their stuff. And here's a great one, PXE. PXE is used to make Windows ghost images of machines. This is where you boot up the machine from the network. Most commonly you see this as an error message in VMware when you're trying to run a virtual machine and there's something wrong with your boot disk. But this can be used to install the operating system over the network for recovery and other purposes. And therefore, what this Metasploit module does is run a malicious PXE server. So now you trigger a reboot of machines, and the Metasploit will feed the operating system to it, and that will of course be a malicious operating system, and this will create a new administrator user and so on, and then reboot the real OS now that it's been altered. So we'll add a new user ID with the username and password Metasploit to any partition scene, and Windows or Linux. So it's good, clean fun. All you have to do is trigger a reboot, and a lot of machines are triggered to automatically try PXE on the way to boot up so that they can easily recover in case of a corrupt machine. Then you can do packet capture on the host, steal the network traffic directly on it like you might with Wireshark. This will do it, and then send the packet PCAPs back to you. This is one of the many reasons why for years I and other people who are in the luxurious position of being able to criticize companies without having to do all the work, said everybody, you should be encrypting your local traffic. But it wasn't until Edward Snowden proved that the NSA had been sneaking sniffers inside Yahoo and other companies to get their local unencrypted traffic. That was what finally motivated all the companies to start encrypting their local traffic. Before that time, they all figured that inside the walls of our building on our wired network, we don't need to encrypt anything because we trust everybody in there. And that's not such a wise idea. All right, then there's shadow copies. Ever since Windows Server 2003, Microsoft operating systems have made automatic backups. They're called shadow copies, and in modern versions of Windows, I think starting around Windows 8, they back up not only all the system files, but all the user files in the restore points. So they make a series of these things, and you can go to System Restore, although Microsoft now has a new term for it, like refresh or something, and you'll see if your machine is running badly, you can say, I want this machine to run the way it ran 2 weeks ago. They'll break up a calendar, and you can pick what date you want to restore to. It will restore your system files or your user files or everything back to that date. These things are great because they have everything in them. They have the registry keys, all sorts of secrets are in there. And this is forensic examiners like these, because if you delete files, and even if you're smart enough to overwrite them so they're really gone, they're still in the restore points. So the restore points are a backward history. I might mention in passing that your best friend is Dropbox. Dropbox keeps the last 30 days of backups of every file. So if you delete everything, you can go to the server and get the way it was 30 days ago, which is handy for you and handy for forensic examiners and cops that want to see what you've been doing and what you tried to cover up. But anyway, you can mount the shadow copies here. This VSS is Volume Shadow Services. That's the process that manages these things on Windows. And you can mount it and then harvest those things over the network. You can find outgoing ports. And you can do Nmap and see TCP listening ports, but you won't see the UDP ports. Anyway, this is a way to essentially do netstat on the target and find out what the this one sends out traffic to try to find what the outbound filtering rules are. We'll try to connect to public machines and see what gets through. And here's one that finds wireless networks, so you can steal wireless information off the machine. I know Kane does this very well. I remember I went to a class at a college and they forgot to give us the wireless password, and I couldn't get the teacher's attention, and I said, well, it'll be faster to just put Kane on this lab machine and steal the wireless password off the machine, and that was quite easy. You can steal WPA keys here with this one. If they are saved in the profile, which they typically are by default, then they're easily steal off the machine. All right, I got some hoots about this. 5 questions. Okay, which module only works if you have a rare feature activated? All right, that's auto login. All right, which module lets you image the whole disk? All right, that's NBD server. I think that stands for Network Block Device. All right, which module gets a plain text password? You know, I think memory grep is a good answer too, but I can't change it now. Sorry about that. I didn't notice there were 2 good answers for this one. Although, in fact, memory grep doesn't work. All right. Which models do defeats HTTPS? All right, you reject the certificate authority. All right, and which module creates new administrative users? All right, that's PXE Exploit. So, Railgun is a feature added to Metasploit, and what this does is give you direct connection to the Windows API. Everything in Windows you do with the API, and if you take the malware analysis class or the exploit development class, we go through this in a lot more detail. Microsoft provides a bunch of libraries, and they're shared by all the programs, and developers just call library functions to do almost everything. Open a window, collect keystrokes, open a network connection, and so on. So you can type IRB, this will open a Ruby shell, and then you can just use commands that include Railgun, and then the name of the DIL, and then the specific API call you want to make. And all Windows developers learn these things. That's how you do everything in Microsoft. You call a library to do everything, and you can specify them directly here. So if you have a session, you're in Meterpreter, then you can go to IRB, then you can run Railgun to do direct call of shell 32 to find out if you're an administrator. And it'll tell you it completed successfully, and it's true because you are an administrator. Now, of course, there are other ways to do the same thing, but this is useful to call specific API functions so you can do anything a developer does. Anything any program does in Windows. And reverse lookup uses Railgun. You can see it in the reverse. Remember, everything in Metasploit is Ruby scripts. And then you can RB, and Ruby is very easy to read, and here it is calling Railgun when it's the WS2_32 library, and this will get host by address. So it's just a way to do a reverse lookup to turn an IP address into a domain name. But many other things are written using Railgun. And then local privilege escalation is a big issue. On Windows, it's very easy. You can just use get system. This usually works because Microsoft has persistent ways to escalate privileges that they don't patch. So this will try a few simple techniques and often work. If they have user account control turned on, that might not work, because the whole point of it is user account control ought to make the secure desktop so all other processes are suspended, and the only thing it will accept is the mouse and keyboard going to that window to approve escalation, so nothing else like a network signal is supposed to be able to do it. But, and it blocks get system. I tried to do it on Windows 7 with user account controlled on, and it failed. Access is denied, the following things were all attempted, and none of them worked because user account control was on. So all you have to do is call bypass UAC, bypass user account control, and this will typically get you in. And the reason it works is because it will use a code injection to inject the exploit into a process that is trusted. This is what Microsoft did after Vista. All future versions of Windows check the publisher certificate, and if the executable is one signed by Microsoft, it doesn't have to get permission to escalate, so all you have to do is compromise one of them, and you can escalate without triggering UAC. And that worked on my Windows 7. I was able to bypass UAC, exploit, and what happens in this case, remember we talked about, I was in session 4. Session 4 went to my server, but was not the administrator. So I had to have bypass UAC, and that opened a new session called session 6. That's where I ended up here. Sometimes you even have to separately connect to the new session. So that's why I say, even if you only have one target, you might end up with several sessions open. All right. So in Linux, it is not that easy. There is not a generic way to escalate privileges. What you have to do is search for some way to escalate privileges. There's a find command that will find all SUID files, which is a common script kiddie solution. The SUID files are files that run with elevated privileges even when launched with users with low privileges, and if you can find one of them and trick it into crashing or into running another command as part of its operation, then you can escalate privileges. Other than that, you have to find a vulnerability. You need a kernel exploit to escalate privileges because the kernel is what enforces access control based on who you are. So you have to get to the kernel and cause it to do something it shouldn't do to turn you into root. There are kernel local privilege escalation exploits about every 6 months on Linux, so anybody that's about more than 6 months behind on their patches usually has one available. In the book they talk about this UDEV product, which lets you escalate, but there's a series of them. Dirty Cow does it, and there's just an endless series of them coming out for each version, which brings me here. If you have some issue you're trying to do. For example, you were trying to escalate privileges on Linux, then you would do uname -a to get the kernel version, and then you can just do search exploit right here, and it'll tell you what exploits are available for that product or that version number. And you don't need the internet for this, so it's kind of good. So here it tells me if I find udev on the server, there are 3 exploits for udev. And these exploits are already on Kali in this location, so you can go there and you can read the source code and figure out how to use them. And here, for example, are Ubuntu exploits, which will exploit Ubuntu 16.04 or 14.04, and as you see, there are a bunch of them, and most of them are privilege escalation exploits. It's quite common. This is how students have owned my server a few times. So here's one of them, 8572.c is the one they use in your book with udev, and it's an exploit from 2009, and you have to pass it a process ID of the udev netlink, which is usually one more than the process ID. You have to pass it a process ID. So you're going to have to find that and pass it up. So here's the exploit process. First you have to somehow publish that code. You're going to have to move it to the server and compile it there. You could copy the file to there. What I chose is to make a symbolic link. So the entire exploit development directory is now in var www.html, so I can upload as many things as I need to. Then you go to temp, wget the file. You'll find it here, 8572.c, and compile it on the host. This is a common procedure. And of course, it'll only work if you have GCC on the host. There are some people that take GCC off the production systems for this reason. And that's not too bad. That would just mean you'd have to compile it locally on a virtual machine with the same version and then upload it as a binary, but it might slow you down. And so now I go to the run, which looks like this. I make a file called run, because the way this exploit works, it's going to execute a file called run. So I have to make the file, and this is just a reverse shell that will just phone back to the command and control center on that port and give it a bash shell. And then I start the listener on my Kali machine with NC on its LVP, which will listen on that port. So now, on the Metasploitable 2, I go to the temp and do wget to get the run up there. And now I have to find this process number, which you'll find in procnet netlink. That is the process number. And I can then find the number here, and now I can run the attack with that process number there, which I got from that command. So I think that's the game here. You have to have GCC, you have to compile it there and run, and here's how the escalation looks. So I grep udev. This tells me the process number, 2739, and I know it's one less than that, so I have to give it 2738. And then it will phone home, and here I am with the shell as root. So that's the kind of process. The thing about Linux privilege escalations is they're all one-offs. You're going to have to find the code. It'll be in a random language, attacking a random product, you know, different on each system. They're pretty much custom, but this general process will usually find one. If this fails, then you just start Googling, see if somebody has an attack somewhere that will escalate privileges. All right, so I got another set of cahoots. Okay, 4 questions. So which module exposes the API? All right, that's Railgun. All right. Which command performs process injection? All right, that's bypass UAC, which is kind of insane. It takes a process which is signed, which means you can trust it, and then modifies it and keeps running, which kind of defeats the whole point. But a lot of Windows signatures are like that. Which command will find your Ubuntu version number? That's LSB release. Uname tells you the kernel version number, but it doesn't tell you the Ubuntu version number, which is very annoying. It's LSB release for Ubuntu, and it's something else for Red Hat. Bloody annoying. I don't know why they don't unify it, but they failed to ask my advice. All right, which command finds an attack from a version number after you've got the version number? Okay, that's search exploit, of course, and a guest speaker next week and a holiday after that, so we won't resume this stuff for 3 weeks. Okay.